Today I'm going to be discussing chapter 18, APIs. So yeah, like APIs are um, basically it's like a connection between different applications, right? And it's essentially you can make an API call to retrieve like certain data from like a website or specific application and use that data within your program, right? So you can access specific data from like the website that you want to access and stuff like that. So you do that by using API calls, which we'll discuss, and setting up URLs using JSON to um, format that data so you can read it properly. And yeah, so over here, firstly you have to import the request module, which helps you make requests, right, to get the data when you make the API call. So set up your URL. So in this case, we're gonna get um, specific data uh, from GitHub, and we want the top repositories with more than 10,000 stars. So we set up the URL, and then this is a continuation of the URL describing what data we want specifically. Then we set up the headers to specify the API version. So over here, and then we make the API call using the request module. We use the get method, and within the get method, we pass the URL and the headers. So that means that we are gonna retrieve data from the URL and the headers, and that's going to be placed in this R variable. Then we print the status code, which basically states if the request was successful or not, and we pass R dot status code right over here. So we'll get the status code for the data within the GitHub repository, and then we convert the response to a dictionary. So basically using JSON, we're gonna basically format the data that we retrieve, and because we're gonna access R, which contains the data, because it's that variable now that made the request for the data, and use the JSON to format it, and we place that data in the response dict variable. Then we print response dict, and when you do that, you get the status code over here, because at first we printed status code, and we can see it's 200, meaning that the request was successful. And then here we have basically the well, in this case we just printed the response dict variable, and the response dict variable contains the data that we requested, which is from the URL and stuff, and it's placed over here. That's for that code. And then here, modifying the code to retrieve more data, basically. So just everything I described, but adding on over here. Yeah, over here we are printing the total repositories, right? So we pass response dict, and what we're doing is in response, because response dict has the data, we are going to index total count. So we place that in a dictionary, and then within the dictionary we index the total count key is part of the dictionary in this variable, which contains the data from the GitHub um, website to retrieve the repositories. So we access the total count over here, so it can give us the value for that. And then for complete results, we index incomplete results key, so we can access the value for that. Then over here we access items key from response date, right? And we place the values for item key in repo dates now. Then we print response repositories returned by passing the repo dates, right, as a variable within this dictionary. And yeah, it will basically count the amount of how do I say, the amount of values within the items key. Over here we index 0 in the response date variable, which basically contains in the repo date variable, which basically contains the data. So we are examining the first repository, so this will access the first repository within the dictionary. And then we print the number of keys and their names. So we're going to use our for loop. So firstly we print the keys, so repo date, and we know repo date contains the value, the first repository, because we indexed it by 0. So we use a for loop here and say for key in the sorted in repo date that is sorted, we're gonna print the key, right? And then here we print the response date. Then in this for loop over here, right, basically repo date, we know repo date contains the first index of the data, so it will basically retrieve the first repository. So we know now for repo date, right, is gonna loop through repo dates, and basically as it does that, we're gonna print the first repository, right? So information about the first repository, because we indexed it by 0. So we have the name, and then we pass repo date, basically gonna index the name. So this key name, we're gonna get the value for that. We're gonna get the value for the keys owner, for the Stargaze count, so basically the amount of stars for that repository, which is indexed by 0. So the first one. Then we're gonna get the value for HTML URL, then the value for this key, and this key, and so on. And then when we print it, or when we run the code, it's basically shown here. All the profiles, right, are shown here. That's because of the for loop, repo date to loop through repo dates, and basically retrieved all those profiles as we were looping through it and accessing the keys for those values. And it shows here the name, owner, the stars, right, so amounts of stars they have, the repository link, and the date it was created, and yeah, description and so on for those top repositories. Cool. Then as for that, over here we are gonna basically just getting the rate limit now. So not the repository, now the rate limit within that data. So we have import request, so we import the request module, and then import time, so we can set the time and date for um, the data we're retrieving. So then we have the URL, they set up the headers, and then we do the requests dot get, and we basically retrieving the URL, the data from the URL and the headers. And then we have we're converting this to using JSON to a readable format, and we place it in a rate limit data variable. Then we have a variable search limit. Within it, right, we use rate limit data, right? We know that it contains the data now for the rate limit, which is from the URL github.com, right? And because we made the API call, and because we passed the data, because we made the API call within R, and we basically passed the data from R using a JSON format into rate limit data. Now we basically gonna access the keys within rate limit data because it contains the data. So we access these keys, rate and limit, and the values for that. We access these keys for, and we pass those values, right, to search limit variable. Access the keys for rate and remaining, and pass the values to search remaining variable. And also with this, pass the store the values in a reset time variable. Then over here, we're just converting it to a readable format for the date, right? So we have this new variable set time readable, and within the variable, we'll set the time, right? So using the time module that we imported, using this method, which will basically format the time. So year, month, day, hour, minute, seconds. And then this basically is to reset the time. So now that's stored in the reset time readable. And now because all that information and data is stored in these variables, we can basically put those variables within strings, so we can print all the data within it. So for the search API limit, we pass search limit variable over here, and that will contain the values that come from these keys. Same with search remaining will be printed, and the reset time readable. And then basically we receive this. So you can see now, because we access the data from those variables which contain like all the data from the URL, you can see the 60 for the search API limit, the result for request remaining, and then the time over there. That's for this code. So yeah, essentially it's the same procedure, just using request.get. What that does is it basically, using the get method, it accesses the URL and the headers, and when it accesses the URL, it now basically has that data, and it's stored in this variable R, and then we access R and use all that data. So yeah, over here now the only difference is now we're gonna use plotly.express. We're gonna use plotly express to basically display the data in a graphic format, so on a graph. So yeah, now what we add basically is an empty list now. So here we have repo names and stars. So because we're getting the top repositories, and we also want to get like the stars, so the amount of stars they have, and these are repositories that have 10,000 stars only. So we filtered that because of this here. We filtered it to show only the repositories that have over 10,000 stars. So now, like, now that we want to use a graph, we have an empty list, repo names and stars. Then we have a for loop, right? Repo dict basically iterates through repo dicts, right? And we know that repo dict basically has the values for the items key. So over here, repo dict, repo name, basically here we are gonna use repo dict to index the name and get the value for the name, right? And once we get the values for the names, we are gonna append that to repo names list, and now repo names will basically have all the names, basically, so all the repository names. Then we append the values for the stargaze count, so the values for stars, basically accessing repo dicts, right? And getting the values for the stars and then appending it to stars, the empty list. Now that contains the amount of stars for all the repositories, right? Then we set the title for the graph, which will be most Python projects on GitHub. Then the labels. Within a dictionary, we have this X and Y as keys, and then the names assigned to it. And then we just use Fig to basically set up or to create and display the bar chart. PX is basically plotly expressed, and we use the bar method to set it up. We passed the repo names list within here and assigned it to X because now it contains the names. We passed the stars list in parentheses and assigned it to Y because now it contains the amount of stars. Then the title and the labels as well over here are passed in here. This will display the information on the graph. This updates the layout using Fig and just sets the font size and stuff. Then we Fig.show. When I run the code, it shows this information and then it displays the graph. So you can see the top repositories that all have stars over 10,000, and basically it just shows a hierarchy of the repositories with the most stars over here. So here's the names of the repositories that we pass to the empty list and access the URL for by making the API call. And then this represents the stars over here by accessing the URL by making the API call. So yeah, that's basically a summary of API calls. So working with APIs, pre-existing API, accessing the GitHub URL and retrieving data by making API calls by using request.get. So yeah, that's chapter 18. Cool.